What I want you to notice in these three examples, I was intentional on the examples I actually picked. I picked an example where the leading term's power was the same, the leading term's power had a higher power in the denominator, and the leading term's power had a higher power in the numerator. So those are your three cases of how the powers can play out as far as being equal or higher in the numerator or denominator. And so that's what these three examples represent here in the red, green, and purple. So in the first example, notice that the powers were the same. In that case, if you think about the coefficient on those leading terms, so I'm just going to kind of go here and write it in. The leading coefficient's 1 and the leading coefficient's 1. Well, the horizontal asymptote will always be the leading coefficient divided by the leading coefficient. So 1 divided by 1 is 1. And so that's why our horizontal asymptote is what it is. So I don't necessarily want you to memorize that, but it's something to observe. So for example, if these were different values, like say a 2 and a 3, then it would be y equals 2 over 3, so 2/3. So in this next example, or the second example, the higher power was in the denominator. Well, when that happens, you're always going to have a horizontal asymptote of y equals 0. And then in the third example, the higher power was in the numerator. When that happens, there will always be no horizontal asymptote. In fact, the way I kind of think of it is if I can do division, there's not going to be a horizontal asymptote. Instead, it's going to be oblique, and I need to go ahead and perform the division to find that oblique asymptote. So hopefully that makes sense. But those are your three cases, and again, you could in a sense memorize that. But if nothing else, go ahead and go through the procedure I showed you for finding a horizontal asymptote. And then if you do not find one, you need to go ahead and determine the oblique asymptote instead.